Hi friends, today we are discussing structural analysis, analysis of continuous beams, flexibility method. In the previous sessions, we discussed the analysis of different continuous beams and portal frames using stiffness method. Today we are analyzing the continuous beams using flexibility method. Before moving on to a problem, let us first look the difference between the stiffness method and flexibility method. In stiffness method, it is used to study both statically determinate and indeterminate structures. In flexibility method, it requires a different procedure to study both statically determinate and indeterminate structures. Stiffness methods yields displacements and forces directly. But in flexibility method, the displacements are not obtained directly, so it requires some extra steps. In stiffness method, we determine the degree of kinematic indeterminacy as a first step, but in flexibility method, we determine the degree of static indeterminacy as a first step. In stiffness method, we calculate reactions and moments, but in flexibility method, we calculate deflections and rotations. Stiffness method is also known as displacement method. Flexibility method is also known as force method. Also, in stiffness method, ds is greater than dk, and in flexibility method, ds is less than dk. Now, let us look at some problems. Analyze the continuous beams shown in the figure by flexibility method. We have a continuous beam here. As a first step, we need to find the degree of static indeterminacy. We have two roller supports and one fixed supports. So in total, we'll have 5 number of unknowns and number of reactions will be equal to 3. So to find the degree of static indeterminacy, we have to do that is the total unknown minus number of reactions. So we'll get the value as 2. Since we have 2 redundants, take any of the reaction or moment as a redundant. So let us now select MB and MC as redundants. The release structure and coordinates 1 and 2 assigned MA and MB are shown in the figure. Draw the release structure and write these values as a matrix. Now we have to apply a unit load at coordinate 1 to develop the first column of the flexibility method. We have to apply a unit load at coordinate 1. A standard results of reactions and displacement are theta A equal to ml by 3 EI and theta B equal to ml by 6 EI for these type of beams. So, applying a unit load at coordinate 1, the deflection at coordinate 1 due to unit force or moment at coordinate 1, that is delta 11, will be equal to 3 by 3 EI. That is, here the moment is equal to 1. So ml by 3 EI, m is equal to 1, L is 3. So ml by 3 EI will gives 3 by 3 EI plus 4 by 3 EI. That is 3 for this and 4. Thus we'll get 3 by 3 EI plus 4 by 3 EI equal to 7 by 3 EI. The deflection or rotation at coordinate 2 due to the unit force at coordinate 1 will be equal to delta 21 equal to 4 by 6 EI. 4 is the length. So it will give a value equal to 2 by 3 EI. Now let us apply a unit load at coordinate 2. So the value of delta 12 equal to delta 21 will be 2 by 3 EI according to Maxwell's reciprocal theorem. Similarly, also we have to find the value of delta 22, that will be equal to 4 by 3 EI. Now we have to write these values in a matrix form. That is delta equal to delta 11, delta 12, delta 21 and delta 22. Develop the matrix. Now we have to find the deflection or rotation due to the applied loads. At application of 100 kilonewton, the value can be found out using the equation theta A equal to theta B equal to PL square by 16 EI, since we have a point load. At application of 60 kilonewton per meter, that is we have a UDL there, so the equation to find will be theta A equal to theta B equal to PL cube by 24 EI. Substituting the values for at the coordinate 1, that is delta 1L will be equal to 100 into 3 square by 16 EI plus 60 into 4 cube by 24 EI. It will have the both the effect of the members AB and BC. So the value will be equal to 216.25 by EI. On BC, that is delta 2L will be equal to 160 by EI. Develop the matrix. Since there are no deflections, that is delta 1 equal to delta 2 equal to 0, write the equation and find the value of MB and MC. Now we have to find the reactions. At beam AB, MA will be equal to 0, MB equal to 68 kilonewton meter. At B, MB plus 3RA minus 100 into 1.5, that is RA will be 27.33 kilonewton. At B, that is in case of BC, the value will be MB plus 4RC minus 240 into 2, that is RC will be equal to 124.5 kilonewton. We know RA plus RB plus RC will be equal to 100 plus 60 into 4, that is 4 is the length, that is 100 plus 240, thus we'll get the value of RB. Next, we have to find the moments due to the load applied, and also we have to draw the bending moment diagram, thus completing the question. If you like this video, like, share, subscribe and recommend Solve Civil. Hope you understood. Thank you.